Okay, so we've followed up. We've done all of the side, angle, side, angle, side business. So now, since we can prove triangles are congruent, we're going to prove that their parts are congruent as well. Okay, and that's what the Cpctc stands for. You need to know what this stands for. All right, so it stands for corresponding parts of congruent triangles are congruent. I'm going to ask you that one again. You can almost guarantee it. All right, so this is kind of common sense. If you prove triangles are congruent, then you can prove any of their parts are congruent as well. Anything that's corresponding will also be congruent. Okay, so in your proofs, you're going to be doing your proof going along. After you prove the triangles are congruent, the step immediately after that is your Cpctc step. Okay, and we're going to do a couple of those so you can see them. All right, so let's start out. You know how this works. Whoa. We're going to start with the givens. Alright, so angle Q congruent to angle R. Angle QPS is congruent to angle RSP. And we're going to mark those on the picture as well. So angle Q is congruent to angle R. And then angle QPS is over here, congruent to angle RSP over here. You notice that the prove step is not triangles now. That's your first clue that this is going to be by Cpctc. Okay? Because those are going to be parts of the triangles that we're going to prove congruent. So we have to prove triangles congruent first. Okay? Looking at the picture, you should see a reflexive in the middle. So we can do SP is congruent to PS because that one's twisted by reflexive. The reflexive property, not reflective. There is an X in there. Make sure you've got that. All right. So if we have that, then right now if we look at our triangles, they have an angle, and a side. So we can say our triangles are congruent. So triangle RPS is congruent to triangle QSP by angle, side. That means that we can prove any parts of those triangles congruent anywhere. We want, and let me highlight this, we want SQ congruent to PR. Those are parts of the triangles that we just said were congruent. So we can prove those by Cpctc. So we say SQ is congruent to PR by Cpctc. Okay? So all this really does is add one step to your proof. It really doesn't do a whole lot. Okay, let's try another one. This just happens to be an umbrella frame. It's in your book if you want to see what it's actually talking about. So start with your givens. SL is congruent to SR, and angle 1 is congruent to angle 2. Alright, and we're going to go mark those on the picture. So SL is right here, congruent to SR. Angle 1 is congruent to angle 2. We want to prove, and I'll just highlight those. We want to prove angle 3 is congruent to angle 4. Sometimes that helps to put color in your picture. So looking at the picture, that means I got to prove the triangle on the left is congruent to the triangle on the right, which means right now this triangle and that triangle, they have a side and an angle. They need something else, and they have a reflexive down the middle. So we can do a reflexive, CS congruent to CS by reflexive property. Okay, so right here is your reflexive property. So now this triangle on the left and the triangle on the right have side, angle, side. So we can say triangle CLS is congruent to triangle CRS, and that's by side, angle, side. So now that the triangles are congruent, we can prove any of their parts congruent as well. So now we can say angle 3 is congruent to angle 4 by Cpctc. It's not always the last step, but it's usually pretty close to the last step. Okay, now there's two proofs left here. There's one there, and there's one there. I want you to try to work those on your own, and then sometime before you come into class, I will work them on one of the boards so you can check yourself and see if you got close. But I'm going to do both of them as flowcharts. Okay? So you can try them as a T-chart if you want. You'll just have to check them to a flowchart. All right? Good luck.